In today's video, we're going to combine two lessons together. We're going to look at Lesson 8 and Lesson 9 on roots and how to estimate roots. Let's go ahead and start off with our vocabulary. There's quite a few pieces to this lesson, but once we get into the actual examples, it goes really quick. To start, let's talk about what a square root is. I'm going to use bits and pieces of information you already know. It says that the square root is one of two equal factors. Let's break that down using things you already know. You already know if I take 5 and square it, square being a term you already know, it tells me to do 5 times 5, which equals 25. If I want to find the square root of a number, I could say the square root of 25. Now, that symbol might be a little new, but we'll talk about what it means in a second. But if I want to find the square root of 25, I'm going to go back and look at its two factors, the 5 and the 5. In this case, they are equal, or they are the same factors. So to say the answer is square root of 25, I'm simply going to say 5. The square root of 25 is 5. In terms of perfect squares are the square of an integer. In my previous example, a perfect square, an example of one is 25, because 25 is an integer squared. 5 is an integer, and 5 squared is 25, a perfect square. The goal is that you will have memorized perfect squares up to at least 12 squared. Many of them you already know, but since we are working a lot with fact fluency, you'll already know what 5 times 5 is or 11 times 11 is, and those are your perfect squares. A new piece is talking about this radical sign. Now, you've already seen me write about it, and that is this symbol here. It just means to find the square root. Now, there's another way you could write that. Another way you can sometimes see written, but it's not mathematically what we would deem correct, would be if there is a little 2 in front of the radical symbol. That is not one you will see very often, but it's one that you kind of need to know what it looks like so you're not lost if one shows up. Another radical you will see is if you put a little 3 on it, that is the cube root. And we're going to talk about what the cube root is next. A cube root is one of 3 equal factors, or one of 3 of the same factors. And that would look like if I gave the example of 5 cubed. That is 5 times 5 times 5, which we've done and said it's 125. If I go back and say I want to know the cube root of 125, I can look back at its factors, 5 times 5 times 5. These are 3 of the same factors, so I just need one of them to state my answer of 5. And as for perfect cube, just like a perfect square, it is cubes of integers. Now, through repetition, there are going to be some of these you guys already know. In fact, an example of my class tells me often what 4 cubed is, which is 64, another perfect cube. Now we're going to look at some examples. The first example I want to look at is if I were to ask you what is the square root of 64? Now, we need to think to ourselves, well, 64. Can I think of factors of 64 that are the same? Well, 8 times 8 is 64. So if I were to talk about the square root of 64, the answer is 8. One way of looking at square roots is to ask yourself what number multiplied by itself equals the number inside that radical. What number times itself equals the number given? Let's look at another type of example. You could be asked, what is the negative square root of 25 over 36? First part I want you to look at is this negative in front. Whenever the negative is outside of the radical, it means my answer is negative. It's an automatic thing. If it's negative on the outside, my answer is negative. So I'm going to go ahead and write that negative again. And I want to break this down. To find the square root of a fraction, I'm going to look at the square root of the top and the square root of the bottom. And you don't need to write these notes out every time, but I'm going to go off to the side and ask myself, well, 25, I know that is 5 times 5. And 36, I know that is 6 times 6. So my answer is negative 5 over 6. It's not a lot of work, but sometimes determining those square roots is going to be the only challenge you have, and it's going to be as simple as committing your math facts to memory. Next example is the square root of negative 16. Now, the trick here is this is no solution. For the purpose of our class, we're only looking at what's called the real number system. That's the whole point of this chapter, is the real number system. Well, outside of the real number system, we have what's called imaginary numbers. And imaginary numbers only appear when we have the square root of a negative number. Imaginary numbers have applications in higher level sciences and maths, such as physics, and you won't see this again until about Algebra 2. For the purposes of our class, we're saying no solution because no number times itself equals a negative number. Now ask yourself a couple examples of these. 5 times 5, that's positive 25. But what about negative 5 times negative 5? Well, two negatives equal a positive, and so again, the same number times itself always comes out to be a positive. Fourth example is you could be asked to take the positive or negative square root of a decimal, in this case 121. Now you might ask yourself, well, wait, haven't we just been working with perfect squares because they're integers, they're whole numbers? Well, I want you to look at 1.21 and think about if you know an integer that looks like that number. When I look at it, I see the number 121, and I know 121 is 11 times 11. It just so happens that the square root of 121 comes out to be 1.1. An example I'm going to add to that is if I asked the square root of 1.69. If I look at 169, and I'm going to extend our thinking of our multiplication facts, that comes out to be 13 times 13. So the square root of 1.69 is the square root, I'm sorry, I'll back that up, not the square root, its answer is 1.3. That's using information we can know, such as our perfect squares of integers, and applying it to, well, what if we have a decimal? Let's just take one more look to see if you guys can establish a pattern. Square root of 0.25. In here, I see the number 25. Well, 25 is 5 times 5. So my answer for the square root of 0.25 is 0.5. All right, we're going to look at some examples of equations. And you guys solved equations a little bit in 7th grade. What you're going to take a look at with me, what if we want to try to use that same idea to solve for square roots? For example, t squared equals 169. And I want to know what t equals. Well, to find that, I'm going to rewrite the problem first. And then I'm going to apply our new skill of finding the square root. Well, the square root of t squared is just t. Now I'm going to look at the 169. One thing to be careful of is this is going to be plus or minus. Whenever we're solving an equation, the square root is always going to be positive or negative. Because if I look at the case of, so side note, 5 squared and negative 5 squared, so positive and negative 5, well, that's 5 times 5 equals 25, and negative 5 times negative 5, negative times a negative is positive, so still 25. So if I wanted the square root of 25, it is positive and negative 5. Two possible choices. So going back over to the 169, I need to now ask myself, well, what is the square root of 169? T equals positive and negative 13. So we'll have to work on our perfect squares even past 12. In fact, in many classes, you almost want to learn up to 20, and we'll see a few examples of those as we go. I'm going to scroll down to give you another solving example. This will be y squared equals 4/25. We're going to follow the same steps. First, I'm going to ask you to rewrite the problem. Next, we're going to find the square root. The square root of y squared is y equals positive or negative square root of 4/25. That's positive or negative square root of 4 over the square root of 25 plus or minus 2/5. So those are examples of finding your squares and your square roots. Let's look at some examples of our cubes. First up is the cubed root of 125. And we did this one in front, but it's good to look at again. I know that 5 times 5 times 5 is 125. So the cubed root of 125 is 5. Next, the cubed root of negative 27. Now earlier, I stated that if the negative is inside the radical, then my answer is no solution. Now that's true if I'm talking about square roots, but not the case when I'm talking about cubed roots. And here's why. I'm going to go with the example of negative 3 times negative 3 times negative 3. Well, negative 3 times negative 3 is positive 9 times negative 3. I get negative 27. So when I have a negative inside of a cubed root, my answer is negative. And then I just need to break it down into its 3 equal factors. In this case, 3. Now, what if I needed to find that out and I didn't know the number? Let's back this up a little bit. Say I need to find the cubed root of 125 and I don't even know where to start. So let me write 125 and let's actually break down its factors. The number ends in a 5, so let's start with 5. And then I try to figure out what is 125 divided by 5. You can do the work off to the side, but we've also done it in class. That is 25. I can't break down that 5 anymore, but I can break down 25 into 5 times 5. And I have now my 3 equal factors, which gives me my answer. Same with negative 27. Negative 27, if I want to break that down, I could first try, well, 27 is 3 times 9. Nine is 3 times 3. Since it's negative on the inside, I'm going to pick a negative 3. Even though I didn't have any negatives written over in my tree, when there's a negative on the inside, my answer is negative. Let's look at third example of the cubed root of negative 64. Negative on the inside, so negative answer. Now look at 64. We've worked with 64 a couple times. You could look at that as 8 divided by 8. And then that's 4 divided by 2. 4 divided by 2. But here's the issue. I need my number to only have 3 of the same factors. So let's look at this list. I have 4 factors so far. And before I break it down any further, is there a way I can put any of this back together to get 3 of the same? I can. Look at these 2's. If I put those 2's back together, then I really can break this down as saying 4 times 4 times 4. These 2's right here are this last 4, giving me an answer of negative 4. It will be best if we commit these to memory, but these are just some tricks to breaking down your numbers in order to find an answer. Now for some examples of solving. You could be asked to solve 8 equals s cubed. I'm going to ask you to do the same thing as before. Start by rewriting the problem. Then, if I want to find what number to the third power equals 8, I need to go and find the root, or in this case, the cubed root. On the right, that leaves me with s. On the left, I need to figure out the number 8. Can I list out 3 of the same factors that multiplied together equal 8? Well, 8 is 4 times 2, and 4 is 2 times 2, and I have found my 3 factors, because I can always check 2 times 2 times 2. Well, that's 4. Bring down my 2. That is 8. So S equals 2. Notice this time it was not plus or minus. The plus or minus will only happen for the square root, not the cubed root. Now, for our final piece, we're going to talk about estimating roots. This is going to be for if I'm trying to find the square root of something that is not a perfect square, we're going to estimate about where the answer should go. So, for example, if I ask you to estimate the square root of 12, to do that, I'm going to pick numbers close to 12 that are perfect squares. Well, 9 is close to 12, and I know how to find its square root. On the other side, 16 is another perfect square I know, and I know how to find its square root. For 9, that's 3. For 16, that is 4. Now, as a note, the square root of 12, 12 is closest to 9, so my answer is closer to square root of 9. So I'm going to say that overall, my answer is 3, because the square root of 9 is 3. One more example. Square root of 35. 35 is not a perfect square. So let's think of numbers that are perfect squares that are close to 35. Well, 36 is a perfect square, and I know how to find its square root. It's 6. Another one that's close, but it's smaller, is 25, and I know its square root is 5. But since 35 is closest to 36, and I know its square root, then my answer is going to be the square root of 36, which is that 6. So we're not finding the exact answer, we are simply finding the estimated answer. On this final slide, I'm going to give you some questions for you to try on your own. Pause the video and then see if your answers match mine. Write these down, pause the video, and then check back for the solutions. Check these out, and if you have any questions, bring them back to class.